by Elad, Eisen, and Eitan Grossman from Hebrew University, Stephen Moran from the University of Zürich, and Dmitry Nikolaev from the Institute for Information Transmission Problems. The title of the presentation is Defining Operationalizing Borrowability in Phonology. Let's invent words. Okay, so Elad, the floor is yours. And I want you to say the title, but you have to start with reading the title now.
Yes. So hi everybody. Thank you, Elitzur. Thank you everyone for coming to our talk about defining and operationalizing borrowability in phonology. I'm Elad Eisen, and I'm here today with Dmitry Nikolaev, Eitan Grossman, and Stephen Moran. We'll begin our talk today with the notion of borrowability and its problems. Then we'll go into borrowability of phonological segments and how it can be defined. Dmitry and I will present probabilistic models of segment borrowing, which allow us to quantitatively assess borrowability. We'll introduce you to SegBo, a new typological database of borrowed segments, and we'll see the empirical results that can be achieved using it. We will conclude with a proposal for a general definition of borrowability. But first, why do we study contact-induced change at all? We do it because it's a very common phenomenon in the world's languages that can shed light on cognition, sociolinguistics, history, and more. It is especially important for typological generalizations because when we see two languages that are similar or different in certain aspects, we want to know whether it's because of contact or not. So yes, we study contact-induced change, but why do we need the notion of borrowability? This is because we know that every linguistic property can be borrowed, but some seem to be borrowed more easily or more frequently. This is why most cross-linguistics research on language contact has focused on borrowability hierarchies or scales. For example, this borrowing hierarchy suggests that nouns are more borrowable than adjectives, which are more borrowable than verbs. But what does being borrowable mean? What is the scale of borrowability and how is it measured? Present definitions of borrowability talk about ease or likelihood, but how can we measure them? Surely when someone says that nouns are more borrowable than adjectives, they mean something that can be measured. But what is this something? Haspelmath points out that a statement like this can have multiple interpretations. It can mean that nouns are borrowed before adjectives, or that if a language has borrowed adjectives, it must also have borrowed nouns. It can mean that languages have more borrowed nouns than adjectives, or that a noun's chance to be borrowed is higher than that of an adjective. What we want to do today is to propose a way to measure borrowability of phonological segments, a way that can also be used in other domains. Borrowing of phonological segments is a common type of contact-induced change. For example, Hebrew didn't have the sound ch until modern Hebrew borrowed words from languages that do have this sound. For instance, the English word chance was borrowed to Hebrew as chance. Notice that the consonant ch was borrowed, while the vowel a wasn't. Another example, less prototypical, is from Mihei, which had the d as an allophone of t, but it became a phoneme due to borrowing from Spanish. So we define segment borrowing as a process in which a certain sound becomes a contrastive segment in a language, or in which a marginal segment in a language becomes contrastive in more domains or environments due to lexical borrowing. It might be useful to note some examples for contact-induced sound change that are not considered as segment borrowing. Ejectives in Northwestern California are an areal feature, but lexical borrowing is rare. The Indian English realization of t as a retroflex is also not the result of lexical borrowing, but of a language shift. So now that we've agreed upon the definition of segment borrowing, I'd like us to agree upon the definition of borrowability of segments, and especially how it differs from frequency of borrowing. For that, we would like to present to you a probabilistic way to think about segment borrowing. Though it contains some simplifications, it can still assist us with this problem. So when we say that a language borrows a segment from another language, there are a couple of events or conditions that have to be met. First, the context situation has to permit borrowing, which means that the source language has to have the segment in discussion, and the target language has to lack it. Just like English that had the sound ch, and Hebrew that lacked it. Finally, words that contain the segment have to be borrowed to the target language using that same segment, just like chance in Hebrew. Now we assign a probability to each of these events. The probability of a language to have a certain segment is simply the segment's typological frequency. That is, if a segment is present in 30% of the world's languages, the probability that our source language has it would be 30%. It is denoted here by the letter F. Similarly, the probability of a language not to have the segment is 1 minus F. As for the last event, we propose to mark its probability with the letter B for borrowability factor, which is essentially what we would like to measure. But what does this borrowability factor mean? It means we define the borrowability of a segment as a conditional probability, and namely, the probability of a segment to be borrowed from one language to another, given an appropriate context situation. An appropriate context situation is, as we said, a context situation in which a language that lacks the segment is in contact with the language that has it. There are many factors that determine the probability of this borrowing to take place, including the frequency of the segment in the lexicon and the phonological systems involved. However, we argue that when averaging on a large enough sample, we are left with a factor that is essentially related to the segment's phonetic and phonological features. And now that we've assigned probabilities to all three components of the borrowing event, we can achieve the combined probability by multiplying the three probabilities we have. This results in a set of quadratic functions of f. We can plot these functions where the x-axis shows f, the typological frequency of a segment, and the y-axis shows the probability of the segment to be borrowed. Each of these curves corresponds to a different value of b, but all of them share the same general trend. The probability is highest in the middle and lowest by the edges, and we can understand why. If a segment's typological frequency is 0, it means it doesn't appear in any language, so no language can donate it. If a segment's typological frequency is 1, it exists in every language and will also never be borrowed, since it is not missing from any language. So these are the predictions of our first model, that very rare and also very common segments would be rarely borrowed, and that the most frequently borrowed segments would be ones whose typological frequency is about 50%, since they are more likely to appear in a context situation that permits borrowing in the first place. And what does this mean for us and the issue of borrowability? It means that if we want to compare segments' borrowability, we can't simply look at how frequently they're borrowed. We have to take into account each segment's typological frequency, which determines how available it is to be borrowed in the first place. And I'm sure you're all eager to see what the data look like, but first we would like to present two additional models, which provide us with additional perspectives to look at this issue. Dmitry.
All right. So I'll just continue from this place. So model 1 is very robust. It takes into account all the typological distributions of segments. and in this way it's very useful. But we may want to incorporate other kinds of data into the model that I'll talk about a bit later. So to do this, we need to take another angle. So the first angle is what we call model 2, but actually it's not a really different model because it gives more or less the same results as model 1, because it's basically what model 1 gives you an expectation. It's a simple binomial model where instead of measuring a probability of borrowing, we try to measure probability of borrowing of a particular number, or particular count of events. So we say that this segment is likely to be borrowed such and such number of times, and this of course follows a binomial distribution which we can parameterize by the b sub s, which is a borrowability, and then we use the same quantities as in the same model in order to first compute the probabilities and then to infer b sub s from the data, and this gives rise to theoretical distributions of probability of different segments based on different values of the probability factor. So this model, as I said, it's very close to model 1, so it's not very interesting by itself. But what we can do with this model is that we can actually incorporate the real contact situations in the world. So then we can only allow languages to be included in the model if they have other languages from which they actually can borrow segments of interest. So in order to do that, we need to have some kind of neighbor graph of languages, and there are many ways to do this. One of the standard ones and often used ones is to use what's called Delaunay triangulation, which is essentially a clever way to connect all points on a plane or on a sphere, is in our case with all its neighbors. And in this way, we can collect all the neighboring edges in the world's languages. But this thing is not sufficient for our purposes because we know that many languages all over the world actually borrowed segments from languages that were more influential than other languages. So for instance, English donated segments to many languages in Indonesia and in Americas. Also Spanish was very prominent in the Americas, as well as Portuguese. Arabic was very prominent in Asia and Africa and so on. So somehow we need to take these facts into account. So in order to do that, we actually piggyback on our own data, which I'll talk about a bit later, and we say, okay, so we know that some language borrowed a segment from English, so then this language was in contact with English, and maybe its neighbors were also in contact with English due to the obvious colonial processes. So then we add these edges to the graph, and we end up with this kind of graph, which is kind of ugly, but on the other hand, it shows very nicely which languages dominated the linguistic borrowing or linguistic influence landscape in the last maybe 100 years or 150 years. So this is our data, another piece of data which we incorporate into the model. So then we combine this neighbor graph with the model 2. What we actually say is that now we can measure borrowability in kind of real world context situations. So we say that a language could borrow a segment if it was in contact with any language that had the segment. So there is a very optimistic assumption that we rely on, in this case, for this particular model, is that we actually need to know what languages did not have the segments. And for this, we had to trust coverage of the probable database, which we consider to be the universe of languages in our case, because it has a very nice coverage of the worldwide phonological diversity. So we say that if something is missing from foible, then very likely this segment wasn't present there. This is an optimistic assumption, but we hope that it doesn't distort our results very much. Maybe it adds some noise, but there is no clear bias in one or other direction. So now our data set. What we use here is a novel data set which is called SegBo, which is the World Survey of Phonological Segment Borrowing, compiled by the authors of this presentation together with many other people. At the moment, it contains around 1,600 observations from more than 500 different languages from the more than 100 different language families. And it covers more or less all the globe. So some regions, unfortunately, are covered less densely than others. So we have a very strong presence in Eurasian Polynesia, but Australia and North America and also Africa to some extent are not as well covered, but we're working on that. But still, it seems to provide a kind of well-balanced sample of the world's languages. So as a data point, we can say that the most often borrowed segment in the world is the voiceless labiodental fricative F. But as Elad has just said, it's very important to actually control for the initial typological frequency of the segments before measuring borrowability. So now we proceed to present empirical results from our model. So first, this is the raw data of borrowing frequencies, where we regress frequency of borrowing on typological frequency. And we see that actually, if we add the curves from model 1, so this is all about model 1, and if we add the curves from model 1, we see that actually segments seem to follow them very nicely. So for instance, this labiodental voiceless fricative, which is a mid-frequency segment in the world's languages, is also the most borrowed one, and also seems to be a kind of very borrowable one. So we see that the most borrowable segments are voiced pharyngeal fricative, voiceless labiodental fricative, voiceless bilabial plosive, alveolar fricative, alveolar affricate, and two more rare segments, which are also highly borrowable, it turns out, because given the chance, even though the chance is pretty slim, but given the chance, they're very likely to be borrowed. So based on this based on this data, we can introduce a scale, but we can also introduce a more general scale based on the aggregate of our results. So first, it seems that consonants are borrowed much more frequently and much more robustly than vowels, both in terms of frequency and in terms of borrowability. Secondly, it seems that fricatives are borrowed more readily than affricates, who are also borrowed more readily than stops. And these are the main results. We can also present some additional data based on features, but these seems to be the most salient points that we recovered from our initial analysis. So then we would like to see if model 1 is actually in agreement with model 3, and it seems that it is. So we see that more or less the same top segments appear in both results. So the most salient difference is the absence of the voice for original fricative here, but this is mostly due to the fact that it's actually pretty rare. So when you restrict the model to using the neighbor graph, which entails some restrictions on what we can actually include there, then more rare segments become less prominent. But maybe this will change when we have more data and clean it up more thoroughly. But it seems that in aggregate, the results are pretty much in agreement with each other, which is nice. So in conclusion, I would say that, in our opinion, the best way to measure borrowability, to give borrowability a concrete meaning, is to say that borrowability is a conditional probability of a given item, or a category, or a construction, or a part of speech, basically any linguistic thing that can be observed and described in different languages. So borrowability is the conditional probability of this thing being borrowed given an appropriate context situation. So as I said, we can cover many different things using this definition of probability. And in this case, we had to operationalize different things. We had to operationalize the neighbor graph, which again can be used for different categories, not only for logical ones. But some things may be operationalized differently for different phenomena. But we think that the main structure and the main idea of the approach is really valid across different subdisciplines of linguistics. So we propose the formal implementation, we propose the operationalized definition of probability and some empirical results, as I said. And the interesting thing is that the project is still ongoing. We add more data, we add more models. You can visit the site and download the data, and we will be happy for any bug fixes or more data points or any comments on it. And we hope to be adding a graphic interface to make the system more usable, and yeah, to maybe come up with different, more interesting ways to look at the data. So this is all from us. Thank you.
Thank you. Exactly in time. Thank you for a wonderful presentation. The floor is open for questions.
I think Balthasar wants to ask the question.
Oh, sorry. Yeah, now I see all the hints.
Thanks.
Yeah, so
this is really great progress, but I was just wondering whether you can relax the assumption of a world of equal probability worldwide for a segment to be present, because we know that probabilities differ between areas. So, for instance, voicing distinctions are less probable in the Americas than, say, in Africa. Also, probabilities of segments differ between families. So prenasalized stops, for instance, are more probable to be detected in Oceanic language than in, say, a Semitic language. So I was wondering whether you can incorporate these differences in base probabilities for your baseline. Thanks.
Yeah, so in the first model, you can indeed change the base probabilities based on the area, but as can be seen from the data, about half of the borrowing events are actually inter-areal. So it's more complicated than that. I did something like this in my master's thesis that can be that's available online. But what Dmitry presented with the map is also accounting for the different inventories in different languages. So it's not about changing the baseline probability, but it also takes into account what inventories are available in every area, or actually in every connection between two languages.
John, please. Yeah, go ahead.
Yes, I wonder to what extent your inventory of the kind of most borrowable consonants can be accounted for by one or two languages of global impact, Arabic and English. So in other words, if all borrowings are not equal, as it were, but some languages have been expanding especially rapidly, I think in the way you've set things up, which I think is it seems like the right way to do it.
Yeah.
By looking for languages that are open to receive a segment, then maybe that's exposing them mostly to these global expanding languages.
Yeah, so also a good question. Also here, Dmitry in a different work showed that that the most influencing languages or colonial languages seem to donate the same segments, but in larger quantities. So they don't seem to shift the types of segments. They just donate similar segments more rapidly.
Could I add to this? It's pretty clear that whatever is going into this borrowability factor is going to be phonetic on the one hand, but also sociolinguistic on the other, right? So part of this, like, situation with, for example, the pharyngeals, it's true that this is really a lot to do with Arabic and the particular sociolinguistic relationship between Arabic and other languages in Western Asia. So in a way, there's a kind of confound involved, because really there aren't in many other donors of these sounds to the same extent as Arabic. So the question is really on point, and I think we need more sophisticated ways of looking at this.